Good morning, everyone, and thank you for joining us again. We are here to discuss today some very cool DevOps magic that we can do, in particularly when it comes to data mobility in cloud-native applications and Kubernetes. Also, we are going to discuss some business continuity and how does that work for cloud-native apps. And we have here with us a few distinguished speakers here with us today. So first and foremost, we have here Daniel Paul, who will introduce himself in a minute. And we have also Oleg Perstein here from TerraSky as well. He's our cloud native team leader. And again, just some housekeeping. If anyone has some questions that they want to bring up during the sessions, please use the Q&A section, and we will make sure to address all of those questions at the end of the session when we have dedicated some time to do so. Daniel, would you like to maybe introduce yourself?
Yeah, thank you. I'm Daniel. I'm responsible for the Portworx business in the German-speaking market, so covering all the DACH region, but also support other regions within the wider EMEA range. I'm a cloud architect, so I'm covering all these topics from a technical perspective. And thanks for joining today.
Thank you very much, Daniel. So I think maybe we'll just jump right in.
Let's just start.
Let's just start. Yeah. Okay, so Daniel, you go ahead and we'll jump in and interrupt during it.
Yeah, so let's starting a little bit high level, but be sure we will go deeper into technology today. So when we meet customers in their application modernization journey, we often see that there is the idea of when migrating to newer application platforms, when doing a rehosting, when doing a replatform, going into cloud native, going into Kubernetes, is something where some organizations think this is a linear process. So over the time, they can migrate all their applications. So over a linear time, they can migrate all their applications into these new platforms. And we all might know that this is not the reality. So when we go to customers, we often see three phases when they do the application modernization or they replatforming into Kubernetes. And these three phases, I think they are really important to find out on which place a customer currently is and where we can support them. So most customers starting with their Kubernetes journey start with migrating stateless applications into Kubernetes. Well, this is low-hanging fruit because, it's quite easy. Kubernetes was designed for this. So, and with stateless, we mean the applications run within the Kubernetes cluster. They get information from somewhere, process these information, and put the information to somewhere else. And somewhere is not inside the Kubernetes cluster. So usually they get information from databases which are hosted outside the Kubernetes cluster, process these informations and put the information back into those databases or into other databases also outside the Kubernetes cluster.
So basically what we are seeing is that customers are using Kubernetes and cloud native apps mainly for the front end of their applications and their services, right? So they still keep hosting all of their databases and the backplane somewhere else, right?
Yeah. But when customers start with this, they learn how Kubernetes is working, how all these processes should be aligned to it. And then they start with putting the first non-critical stateful applications into Kubernetes. And why this makes sense, Ariel will talk about in just a second. So, but they start now putting non-critical stateful applications onto their clusters. And in this point, they figure out, well, we need to find out how Kubernetes is doing stateful applications. There are several ways. Each platform offers own ways how to do this. Each Kubernetes distribution brings its own technologies to be integrated to those platforms. Or if you have an on-premise environment, you can integrate your storage vendor software. So people now in this phase two, start thinking about how is stateful application living in Kubernetes. And this slows down these adoption curve of application modernization. And the third state is quite an interesting one, because if they were successful with putting non-critical stateful applications into Kubernetes, they now start thinking about how to put critical stateful applications into Kubernetes environments. So this means your business critical information, your databases, all these things which are relevant for your business. And this is the third phase we see in customer environments, where it often comes into scale, where it often comes into hybrid deployments. So meaning you have on-premise, you have public cloud, or you might think about having multiple public cloud vendors. And when you bring the state into this, you need to take care about how your data is migrated between these platforms, or how your data is protected on those platforms. So in this third phase, often customers start rethinking these processes. And there are technologies coming into play like HA, like migration, like disaster recovery, everything you already might know from your existing IT environment, but you need to adapt this, and you might need to also change your thinking process to put this into Kubernetes environments. But first of all, let's have Ariel talk about why you should put stateful applications into Kubernetes.
Thank you, Daniel. And this ties into what Daniel just said, right? Because usually when people go towards adopting Kubernetes and adopting this cloud native mindset and way of doing things, we normally don't do it on a whim. We do it because we have some very, very good benefits of using those platforms, because we want to have something that's more agile, more fast to consume and to develop onto, right? We love features in Kubernetes like being stateful, right? Self-healing. We like those features because it solves a lot of the headaches and a lot of the pain points that sometimes we have with more traditional approaches, right? And obviously, well, if it's good enough for adopting it for our, let's call it the phase 1, phase 2 applications that Daniel just mentioned, right? Like the low-hanging fruit, the stateless apps, the front-end apps, all of those things. Well, we do want to have those benefits also for our stateful apps, for our core applications, for our databases, for all our critical organizational data. And this makes a lot of sense for people until they reach that point that they say, well, but what's going on with my data? How do I manage it within Kubernetes? Because as we all know, it was not meant to host stateful data at the beginning when it was first introduced, right? And nowadays, we have very good solutions in order to actually go ahead and do those things and do manage data, stateful data within Kubernetes, and adopting this framework in a way that our entire production stack will benefit from all of those very, very cool things that make us all love Kubernetes. Right, Daniel?
Yeah. So when it comes to persistent storage in Kubernetes, Portworx is the leading platform to go to. And let me quickly talk about what we are offering before digging deeper into the actual architecture, so how we solve these problems. When talking today about Portworx, I will mainly talk about Portworx Storage, which is our core product, which offers this stable and HA-capable platform for Kubernetes persistent storage. And part of these platforms are disaster recovery, migration. I will dig deeper into this today. It's also about Portworx Secure. I will shortly mention this. And when talking about DR and migration capabilities, you also need to talk about backup, because this is also necessary to prevent you from human error or from other errors which could happen. So we also have a product called Portworx Backup, which takes care about backing up and restoring persistent data from Kubernetes cluster. And it also helps you to migrate your backup and restore processes more into a self-service way, because what we also see at customers deploying Kubernetes infrastructures, the developers demand self-service. So it's no longer good enough to have a backup and restore process, which is just ticket-driven. It's more about people who want to be responsible for their own data. They want to consume the data and they want to be able to do self-service. So with Portworx Backup, we can also offer this. You can run Portworx Backup in a classical way, like you already do backup. So meaning you have a department responsible for backup and restore processes, but you can also migrate this more to a self-service way where people can just onboard their Kubernetes cluster and take care about backup and restore by themselves, or you can do something in between where you transfer more and more processes to the user to enable self-service. And the last
Now,
but not, yeah.
Sorry to jump in, but before we actually start to talk about like deep diving into how does it work and what does it do, a few things that I really want to mention for our audience to be aware of. When we're talking about Portworx, we're not tying into any specific infrastructure or any specific Kubernetes distribution or to running a particular set of apps, right? Some of the unique things that we have in Portworx that it's completely agnostic, meaning it's fully cloud native. It can run anywhere, right? The same way we want our apps to be able to run on any type of platform, whether it be on an on-premise setting or maybe in public cloud or in a hybrid scenario. We want our apps to be running everywhere flawlessly. Same goes for Portworx. So with Portworx, we are not tied into any specific distribution or any specific infrastructure. We can have it running on our Kubernetes clusters, whether it be on EKS, GKE, AKS, OpenShift. We have tons of customers using it on OpenShift, right? And basically, we want to be able to consume all of those features that we can provide, no matter where you are, no matter where you want to run. You might be on OpenShift today, maybe tomorrow you'll be using Tanzu. You might be using one cloud provider, maybe right now you're on Azure, maybe the next day you're going to be on AWS. We want to enable you guys to do that. We want to be able to give you an experience of true cloud nativeness and true flexibility. So this is something that's very important to understand regarding the Portworx platform.
Yeah. So with Portworx, and that's just one sentence you should remember, with Portworx, storage looks always the same, no matter where your Kubernetes is running, what platform you have, what's the infrastructure underneath. Because what we see with other customers trying to achieve this without Portworx is, yes, you have storage implementations for each and every platform on every cloud, but the problem is when it comes to consumption, when it comes to snapshotting, all these things, it might look different on each of your platforms. And this is against the basic idea of containerization in Kubernetes. It's about standardization, it's about automation. And with Portworx, you can achieve this. So with Portworx, storage looks the same regardless of the underlying Kubernetes infrastructure or distribution. The last point here, yep. Please.
So I think because we want to be on time, I think maybe we'll just dig into now just how we make it happen and what makes it tick, right?
Let's start with it. So it always starts with a Kubernetes cluster. So one Portworx installation is always be tied to a Kubernetes cluster. It's being deployed using an operator. It's being configured using YAML specs. So it's a fully Kubernetes native application. Portworx inside the Kubernetes cluster creates a custom resource definition called a storage cluster, and this is our virtualization layer. And our basic design principle is we take unused block storage from the Kubernetes worker nodes, bring this into a pool, and on top of this pool, we serve all the storage needs of your application. And on top of this pool, we also do all the magic Portworx brings into the clusters. Out of this pool, you can create your volumes using the well-known persistent volume claims and storage classes. So you can create your volumes in your Kubernetes cluster, which are being created by Portworx. Volumes can be read-write once or read-write many volumes. But again, just remember the basic design principle. We take unused block storage from the worker nodes, bring this into a pool, and out of this pool, we do all the stuff Portworx can do.
So now, you are telling me basically I can use any block storage or any block device out there to basically create this pool?
Yes, we take all the block storage a platform can offer, and out of this block storage, we build our storage solution.
So if I have maybe an EKS implementation and I'm used to working with EBS CSI and EBS devices, will that work for Portworx?
Yes, it will work, and it will work perfectly because on these platforms where we have a virtualization layer in between, so meaning Amazon, Google, Azure, or vSphere, we have another component called the orchestration layer. And the orchestration layer is connecting to these virtualized infrastructures. And yeah, you mentioned Amazon, EKS, and EBS because if I say we take block storage from worker nodes on this platform, this is technically more precise to be described as it's an EBS volume on an EC2 instance. Yeah, for example, when you're running on vSphere, it's a VMDK being attached to a VM. So with this Portworx orchestration layer, we can integrate into those virtualization platforms, and we can create the storage we need by ourselves. So for example, you can tell Portworx, hey, you're running on Amazon EKS. I want to have each worker node contributing 1 terabyte of storage to the pool. Then Portworx at deployment would go to the Amazon API, would connect to it, and would deploy a 1 terabyte EBS volume to each of your worker nodes. And at the point the deployment is ready, your storage system is ready. So Portworx would automatically deploy the needed storage to the worker nodes. This works on these virtualized platforms. If you're running Portworx on a bare metal cluster, for example, you need to take care by yourself of providing your worker nodes unused block storage, which would mean in a bare metal cluster, you plug HDDs or SSDs into your nodes, or you attach a LAN, for example.
And by the way, we do have a few and even many customers doing the exact same things, maybe running those bare metal nodes with something like OpenShift, for instance, and actually utilizing Portworx as an orchestration layer and basically to mask out the entire storage plane, right? Maybe using some local SSDs to create like a fast tier for the cloud native application, right?
Yeah, so and from a consumer perspective, storage now looks the same regardless of the underlying infrastructure. So this is how Portworx storage basically works. So now we have the storage system ready. And now let me tell you about why you should do this stuff, because this is another layer you put into your Kubernetes cluster. It needs to have some benefit for you. And the benefits we have as well, we can create multiple storage classes, which is kind of basic stuff, but your workloads can now consume block and file storage, whatever they need. We also can offer different levels of performance. So whenever a worker node joins the cluster with local block storage, we will benchmark this block storage and we will categorize it. Is it SSD? Is it magnetic? Is it slow, medium, or fast storage? And we can also offer multiple protection layers. Because if I say we take the block storage from worker nodes, we also need to react on the event that a worker node is lost. And you don't want to lose your data. And this is about HA within a Kubernetes cluster. I will dig deeper into this on the next slides. From a consumption layer, we always work application consistent and application granular. What does this mean? For example, if you want to do now a snapshot of your PVCs, Portworx knows that Kubernetes could have a namespace, or Kubernetes will have a namespace. And within a namespace, you can run multiple replicas of an application. So if you want to snapshot this application, you need to bring all the replicas in a consistent state. You need to snapshot all the volumes at the same time. And then you may also notice the application that it can continue. And all this is natively implemented in Portworx, and it's all managed by YAML specs. And again, it's independent from the underlying infrastructure. So if you define this once for your application on an on-premise environment, this also will work on the public cloud and anywhere else.
Which really makes it simple and easy to consume, right?
Yeah.
If you have the same thing running in all of our environments, whether they be on-premise, in the cloud, that simplifies a lot of our daily operations.
Yeah, just put it into your Git repo and consume it everywhere. And this is the idea behind the standardization and automation in Kubernetes. And we can also offer capabilities for encryption. So with Portworx, you can encrypt all the data which is being placed on these worker nodes. So it's encryption at rest, and it's enforced at the Portworx layer. And again, you enforce it on Portworx, not on your underlying infrastructure. So you configure it once and you can deploy it everywhere Portworx is running. And with this abstraction layer of Portworx, we're also now able to replicate your data between different Portworx and Kubernetes clusters. And this is the main topic today. So we use this capability of replicating data between Portworx clusters to implement, for example, disaster recovery. So with Portworx, we can do sync or async disaster recovery between different Kubernetes clusters. And again, this is independent from the infrastructure. So we have customers running on-premise Kubernetes and doing a DR into the public cloud, or doing DR between different regions of the public cloud, or even between different public cloud vendors. So there are no limits between for cloud or on-prem, so for the hosting model or for the infrastructure. And it's even working for different Kubernetes clusters. So you could run on-premise OpenShift and replicate to Amazon EKS.
Which is, I think, very, very powerful for everyone thinking about adopting a multi-cloud strategy, right?
Yeah. This brings all the DR and HA capabilities you might know from your classic infrastructure into the Kubernetes world for the stateful data. And the same capabilities we are using for DR, so these replication capabilities between Portworx clusters, we also use for just do migration between Portworx instances. So for example, you can now migrate namespaces from one Kubernetes cluster into another Kubernetes cluster. And we will include all the Kubernetes objects and all the PVCs objects of your deployments in this migration process. And this is being used, for example, to do troubleshooting. So you have your production environment and there is an issue with your application. You don't know exactly, is it the application, is it the database, is it the data inside the database or something in combination? Then you can just snapshot a whole namespace and migrate it to your test and dev clusters. So your developers can do the actual troubleshooting. And again, this is not limited by Kubernetes distributions or a hosting model of Kubernetes. So are there any questions about this or any comments on this before I go deeper into some more details of our platform?
Well, I don't see we have any questions right now in the Q&A. What I think we'll do is we'll move up with the sessions and we'll dive deeper into how we do those things.
Yes.
And then I think some questions will definitely pop up.
Yeah. So first of all, HA for persistent storage. Let's talk about how we secure your data within a single Kubernetes cluster. Your Kubernetes cluster consists of multiple worker nodes, and as I've shown in the architecture, these worker nodes can have block storage attached to themselves. So here in my example cluster, I have 5 worker nodes. 4 of them have storage attached. The 5th, by intention, does not have any storage attached. You deploy Portworx, we build this storage pool or this storage layer on top of the worker nodes. And now think of you want to deploy a single instance Postgres database to a worker node. So this Postgres will be placed on worker node 1, where it will consume the 50 gig PVC, which was deployed for this workload. So worker node 1 will have the data local on the SSD. Now, to prevent the loss of data when losing the worker node, you can define replication factors with Portworx. So this means you can have a replication factor of 2 or 3, and we will create a copy of the data on 2 or 3 worker nodes of your cluster. This is topology aware. So if you have a multi-AZ Kubernetes cluster, these copies by default will be placed in different AZs. And now you have a synchronous copy of the data within your cluster. And in case you lose one of your worker nodes, so here, for example, you lose worker node 1, the Kubernetes scheduler will now try to place the workload on another worker node. So we will work with the Kubernetes scheduler and set filters on the worker node. And worker node 2 or 3 will now have a better rating within this election. So the workload will high likely land on worker node 2 or 3, and there it will just consume the copy of the data which is there. So this is a fully automated process. You don't need to touch anything. This is just happening within seconds. So now Postgres will come up on worker node 3 and will just continue to work. But just think of maybe worker node 2 or 3 are not available because of memory constraints or CPU constraints. Then in this case, your worker node can up on each and every worker node of your cluster, and Portworx will again automatically in the background create this volume on this worker node, and the data access will be pointed to over the network to the worker nodes which have the actual copy of the data.
That sounds amazing.
Yeah, it is. So this is fully automated, and people are often very fascinated if they see this working. Without any intervention, the Postgres pod will just come up and work. So, yeah.
So actually, it ties into the benefits of really having an app continuously running, whether we have an error or maybe an AZ failure or whatever it may be. Our apps will just keep on running. That sounds good.
And this is how we keep data high availability within a single Kubernetes cluster. Now, just one word to work on it. One, if this will come back within a certain time, it will be just synced with the deltas. If it does not come back, we will create the third copy on another worker node of the cluster. So also this is an automated process. You don't need to interfere here.
Sounds amazing.
Yeah,
well, let's talk about what happens when we have more than one cluster.
Yeah, so now we are talking about what actually happens when you lose a single Kubernetes cluster or a full Kubernetes cluster. And this is about data mobility and disaster recovery. And maybe, Ariel, you will say something about the use cases.
Yeah, because, well, we've talked about a lot during this session about, well, how do we keep things alive? How do we keep things running? I actually want to tie this into actually a few other use cases that we might have usage for those capabilities of replicating data and migrating it between Kubernetes clusters. Some of them might be, and I'm not going to talk about everything in depth right now, but the most important thing, and this is something that comes up a lot when we talk to customers that are actually facing those issues. What happens when I want to simply upgrade my Kubernetes cluster to a newer version? Some APIs may be deprecated. I need to know how this might affect our apps that are currently running, right? We don't want to have an issue when we upgrade our Kubernetes cluster and all of a sudden production down on a weekend, right? We don't want to have those things happen to us. But if we can maybe use those features to actually take a copy of our actual data on everything that's running in our namespace, all the CRDs and everything the app actually needs in order to run, and basically clone this or migrate this into a separate cluster that has the newer version, we can actually look at it, test it, and see if everything's validated before we actually go and commit to an upgrade on our production environment. This is one use case that we actually see very often comes up in our conversations. Another thing that might happen is maybe we want to deprecate an older environment. Maybe we have an on-premise environment that is running and we want to just take it out, lift and shift it into the cloud. How do we do that? How we go about it? We can basically use those tools to take the entire namespace, again, with everything that's tied into it, with all the config maps and everything that the apps actually need in order to work, and to lift and shift those into a different cluster elsewhere. Might be in the cloud, maybe in a different on-premise environment, on a different distribution, who knows? But these are the types of things we want to enable people to do. Obviously, some of it actually ties into what we've discussed, which is disaster recovery and how we enable our business to continue to operate, to our production applications to continue service our customers in case we have maybe an error or an issue, and this is what we want to dial into next.
Yeah, so this is about the async DR and migration capabilities of Portworx. So think of you have a production cluster here running on the left side with namespaces running Postgres, MongoDB, MySQL, and Portworx is now providing these highly available storage within the cluster. And now think of you need a disaster recovery strategy, which just enables you to fail over to another Kubernetes cluster in case, for example, your on-premise deployment fails. So you can create a so-called cluster pair between Kubernetes clusters running Portworx. And these cluster pairs are YAML specs, so you can integrate this into your automation workflows. And now we create a connection between those two clusters. So we have a source and a destination, and the source here is cluster 1, destination is cluster 2. And again, here's no limit between cloud, on-prem, or hybrid approaches. So this is only happening on the Kubernetes layer independent from the underlying infrastructure. So you create these cluster pair, and you could have multiples in your clusters. And after you created this cluster pair YAML, you can create a schedule which says how often things could happen. And at the third, you create a migration. And the migration is on the namespace layer. So you can say, I want to have the Postgres namespace, the Mongo namespace, and the MySQL namespace to be migrated using the cluster pair between cluster 1 and cluster 2. And what Portworx would now do is, following a schedule, it would snapshot the production environment on the left side. These snapshots can be application consistent, as I mentioned, and then we will transfer these data using an object store into the second cluster. So now every 5 minutes, Portworx will snapshot your data on the left side and will migrate it to the right side. And if you would take now a look into cluster 2, you would see all your PVCs, you would see all the volumes, you would also see all the Kubernetes objects, with the only difference that the replicas are being scaled down to 0 because this is async DR and you don't want to have your application running on the second cluster. But in case of a disaster, there's just a single command you can issue against cluster 2, which will take the original number of replicas and will just scale them up in cluster 2. So your application and all its stateful data will now be back in cluster 2. You might have to solve some issues regarding the ingress and how to achieve this cluster 2, but we can ensure that your application and your application data is there and is up and running. So this is our async DR use case. We do technically the same if you do a migration. So you can also use this here to migrate namespaces from cluster 1 to cluster 2. The only difference here is this is not following a schedule. A migration is a one-time job. So you issue a YAML that you want to do this migration. And again, all this is YAML driven. And then Portworx will just migrate or copy the namespace from cluster 1 to cluster 2.
Now, I do want to mention that for our audience, right? There are some stuff that, like Daniel mentions, that we will need to resolve in order to make things work. So this is not 360 taking care of absolutely everything in our Kubernetes deployment, right? There are some things that we also need to consider while we are doing those types of migrations. We need to take care of secret management replications. We need to take care of our ingresses, our load balancers. Everything needs to actually be taken into account while we are doing this. So just bear in mind, when we do those things, there are a lot of considerations that we need to address. So this is something that needs to be put out there, you know, for everyone's sake, right? But what we do here really solves a huge portion of the issue of how the hell do we get out of one cluster and moving data to another cluster, whether it be, like we've mentioned before, on a schedule, something we can do periodically, even on a 5-minute granularity, and then we'll have the return point objective of 5 minutes tops. We can actually do even, you know, we can stretch it out even more. Depends on your needs, obviously. And again, we can do single one-time migrations on command if we do want to phase out from a cluster, maybe to, I don't know, for some maintenance or some permanent migrations.
Yeah. So just as a reference, as I said, we create just YAML specs. We create the cluster pair. We need an object store to sync the data. We create a schedule policy, which is a YAML spec and defines when to do stuff. And we create a migration schedule spec, again, a YAML spec, what defines just what we want to migrate. So we can also exclude some stuff if we don't want to migrate this, and this runs on a namespace level. Just to be complete in the view, I was talking about disaster recovery, about async DR. What we also can do is a sync DR, but this would technically mean we will stretch the underlying Portworx cluster between two Kubernetes clusters. There are limitations when it comes to latency, when it comes to the overall architecture, but technically we can do this. And this is an architecture which is heavily used in the banking sector, for example, because here we can achieve an RPO of 0. So this means whenever the Postgres pod writes data into its volume, this data will be replicated synchronously to the other Kubernetes cluster, will be there and will be acknowledged back to the Postgres as soon as it's existing in both of these copies. So now we have a synchronous replication of the data between those two clusters. And in each point of time, we have the copy of the data here on the second side. And again, by default, we scale down the replicas to 0 because we cannot have two pods writing into the same volume at the same time in this architecture. And in case of a disaster, we can just spin up with a single command the pods in Kubernetes cluster 2, and they will see all the data with an RPO of 0 being available there. And you can just continue your production.
And this is very valuable for, like Daniel said, for the banking sector, for the defense sector, or for places that actually We just want to have the best protection, the best business continuity for our cloud native applications. Because, well, again, we live in a world when it makes a whole bunch of sense to run our applications in a containerized fashion. But we want to enable you guys to do a lot more than just running your front end or your stateless apps on those platforms. We want to enable you guys to have your entire production stack running on top of Kubernetes without being, without needing to worry about, well, what happens if I have a cluster-wide failure, if I have maybe an entire region for my cloud provider go down, right? Those are some of the concerns that we actually see on a daily basis when we talk to our customers. The need for either comply with certain regulations or certain policies that you have in your organization, or maybe you just want to make sure you have the appropriate plan Bs for when things go not as planned, right? Even if we're looking at not only cross-regional, but also on a cross-cloud platform disaster recovery, we can do those things. Obviously, using this solution of MetroDR, basically when we stretch out the cluster, like we just now mentioned, it does take some more planning in order to see how we can actually define everything to work according to your needs, to what your infrastructure is capable of doing. Obviously, there's some cost tied into this, right? You might face some more charges on egress and egress due to those types of architectures, but we think the benefit here really, really, really makes it a unique solution that really benefits people who want to run production-grade Kubernetes environments.
Yeah, so there is many more Portworx can do for you, and we are happy to talk about this. But now we will just jump into a live demo
yes,
about our migration and DR capabilities. So I will hand over to Oleg, stop sharing,
yes.
and yeah, happy
to
see what happens.
And by the way, if anyone who attends this has any questions or would like to have us address a certain topic or dive deeper into something, please use the Q&A chat box to let us know that you have a question, and we'll be happy to address it. So here we have Oleg. Oleg, I will let you, you are muted, so feel free to unmute yourself. So we have here Oleg Perstin. Oleg is our team leader for cloud native apps and DevOps and DevSecOps here in TerraSky. And well, I figured he is the best suited one to actually show you guys this type of demo, because he's actually the one who goes out and meets our customers, and his team, the professionals working under him are the ones going out and implementing those solutions with all of our top tier customers running production-grade Kubernetes applications. So Oleg, please, you can unmute yourself and let's begin.
Hi everyone. So I'm Oleg. I run the delivery team, the team that actually makes the things done. And we want to show you that all the topics that Daniel and Ariel covered up until now, how they look like in the real life, how the under the hood is working, and how simple it is, not only just in the presentation, but in the actual implementation. So Daniel mentioned that everything is YAML based. So here we see the migration schedule YAML. This is actually the policy that by this policy, the migration is scheduled. And we see that the policy name is 5 minutes policy. So we can configure the replication scheduling. We see the namespace that this schedule is replicating, and we even and we can control that what will happen on the other side, whether the application will be scaled to 0, so we will save some resources on the other side, or it will actually start the application after every replication cycle, and then the RPO will be actually 0 and not we will not have to wait till the scaling up. So it will waste us some resources, but will make the recovery time very, very quick. And we also have the cluster pair YAML file. So this defines the pairing between those two Kubernetes clusters and how all the permissions definitions and all the endpoints that we need to define to introduce those cluster one to each other. So you see a very simple information that you present to Portworx, and this pairing is in place. So after we have all those definitions in place, we can see like this is the source cluster that runs our applications. We can see the pods that this application is built off. So we have the WordPress, the front end, and we have the database, MariaDB, that runs on the source cluster. And now we want to see how it looks like, how our web page looks like. We have several posts here, and we want to put another post in our blogging application. So we have we will have a new post from webinar, from Portworx webinar. And we will see how we will actually replicate it and make it work on the other side. So now the data is written into the MariaDB database. And now let's create this migration custom resource. We apply the file that you see in front of you. So the migration is created. Now the data is being migrated. Let's see that it actually happened. And let's see what is the status of this migration. Everything is done, like you see, through the basic Kubernetes commands. You see volume migration has started. So all the data is visible to you. Let's see if it's completed. Let's wait a few seconds until the full backup will complete. And after we will have the backup complete, we will open this destination cluster, and we will make sure that everything is in place. One moment.
In the meantime, this is running. We just want to make sure you guys are able to see actually what we're doing and to highlight a few things. First and foremost, everything is very, very easy to consume for any DevOps engineer out there, right? This is using tools that you are familiar with. There's nothing to actually, to ramp up to and to learn from scratch. It's very, very easy to ramp up and to understand how to operate Portworx within your environments. Secondly, as you can see, that the replication that we are doing could take time, and it definitely depends on several key elements, like the amount of changes that we had for our data, the amount of data itself, obviously, and also for the networking that we have between our clusters, right? So that might, so your results may vary, right? But again, this is just a demo environment. We don't have the biggest resources to use in order to show you this. But if you want to see something that's more up your alley, please feel free to reach out to us to schedule an appointment. We'll be happy to show you even some personalized demos or even run some POCs in your environment and really to show you how this can solve all of your data mobility and disaster recovery needs within Kubernetes. Oleg, go ahead, take it away.
Now you see that the status of this process is successful. So let's go to the destination cluster to see what happens there. In here, we haven't done anything. Okay, we didn't run any Portworx command. We didn't create any custom resources. And we will just wait for the WordPress namespace to be created here, because we performed a sync for the WordPress namespace, as you can see in the definition of our migration scheduling. And as soon as this namespace will be created, we will see that we have all the data restored and replicated at once. And this process can be done regardless of our type of cluster. So the source cluster can be an on-prem OpenShift cluster, and the destination cluster can be either another, here you see the WordPress namespace has been created, and the destination cluster can be another on-premise cluster in different site, in different region, in different physical location, and it can be also between clouds. So the source cluster can be GKE, the destination cluster can be on EKS or different cloud providers, because all those commands, as you can see, they are not tied to certain Kubernetes flavor. And as soon as you have this pairing, so all those processes will function exactly the same, regardless of either your storage provider or your Kubernetes flavor, or even the location of the Kubernetes, either on-premise or in the cloud. So now we see two clusters, and we go to the destination cluster, to its service, and we see the blog post that we just created and was written into the database. Hello from Portworx webinar. You see also our previous writings. So you just noticed how easy and how GitOps it can be implemented in a GitOps way. You just create in your repository the proper YAML files or Helm charts or whatever manifests you want to implement, and you put in the basic information, the scheduling policy, and how do you want it to be recreated in the other side, and it will just work as a magic. As you can see, the backup, the restore, the mobility, and you have all those functionalities of either a disaster recovery or just simple tests that you want to see how your application function in some in the cloud after it was functioning in your on-premise, or you want to debug something in your just-in-time created cluster. You can test it in the most simple way without having big CI/CD pipelines or whatever infrastructure that you need to create to replicate your application to different location.
Amazing.